All right, we are now recording, so be aware. So I'm going to go back and share my screen again. Thanks, Larry. So when we start thinking about what happens as we get through this challenge, and the exciting part is we can kind of see the light at the end of the tunnel now. It's the darkest days, but we can kind of see the vaccines coming out and envision that maybe in 6 months or 8 months or 5 months, that things are going to be a lot different. But I think from the commercial building side, we're going to have some ongoing challenges here. And the biggest challenge that I see is just how we get building owners and building occupants comfortable and confident that buildings are healthy and safe. A lot of folks I know today aren't allowed to, but don't want to go and sit in their offices or go into a restaurant. And we have a challenge with helping make people feel that things are healthy and safe again when we're back to a lower issue of pandemic. Um, I think we also have a challenge that a lot of things changed the last year. All of a sudden everything's on Zoom, everything's work from home. I was very shocked to see a comment from the CEO of Delta Airlines saying, we don't think that business travel will ever return to the level that it was in 2019. And that's a really telling statement. And he's right. It used to be that we had to jump on a plane to do this, or we had to fly out to see a client to do this, and suddenly we don't have to do that. So, if you think about what we're doing with remote learning, if you think about what we're doing with work from home, if you think about what we're doing with telehealth, some of those habits and practices are going to continue. Not all of them, and I don't believe that everybody's forever going to be doing everything from home. But I talk to a lot of folks that say, I'm never going back to the office the way I did before. I'm going to go back 2 or 3 days a week, but I'm going to keep working from home more. So that's going to impact how people use buildings. Um, we have an ongoing issue, and those of us that are involved with ASHRAE and other efforts have worked diligently for many, many years to try and improve the energy efficiency of commercial buildings. Um, I'm excited as we see a new administration coming in and a new focus on this, that we're going to see a continued push on this. So we need to keep thinking about how we're going to get better efficiency. I saw Leonard Leon's slides yesterday saying, oh, if we increase ventilation, it only uses 20% more energy in commercial buildings. Like that's a big deal. We need to do more research in a lot of areas, and my next slide talks more about that. But we need to know more about what really happened here. How did things move around buildings? Did it move in aerosols? Did it move in fomites? What happened, and how do we deal with this? And what can we use to disable it? And we need to think about what's next, and whether, from a buildings perspective and building systems perspective, if we ever really go back to normal. It's interesting. I'm seeing a lot of things going on. These are two slides that I'd like to share with you. The one is a restaurant I walked by the other day. It was closed, not surprisingly, but I'll read you the sign that was posted on the door. It says, cleaner and safer air. It says, we've installed an air filtration system that sends out high concentrations of positive and negative ions into the air. This happens to be what's called a needlepoint ionization system. I know what this is, but it's interesting. Does this impact if you decide to go to that restaurant or not? Is this a safe and effective system? I have a building owner I'm working with that I did a major energy retrofit project on, and they said, what do we need to do? And I said, we need to come in and recommission, and we need to follow the ASHRAE guidelines. And the owner came back and said, no, I need to go in and install needlepoint ionization. I said, okay, I don't know if that's an effective solution or not. And we need to learn more. I'd like to know if it's effective. On the right-hand side is another solution. This is a solution with a ceiling fan, high volume, low speed fan that has a UV light mounted on it. They brought it into the lab. It seems to be a pretty well thought out solution. Whether it's truly effective or not, I don't know. And I'm not sure that any of us knows. So, these are solutions that people are trying out and innovating and doing some things with, but they may or may not be the right thing. We have a lot of work to do as an industry to figure out what we need to do next post-COVID. We need to build a roadmap that helps us figure out how we're going to develop and deliver both new buildings that are highly energy efficient and highly healthy, and how we're going to go back into existing buildings and help them do that. There's work needed on some basic science. Did this move as an aerosol? Did it move as a foam? like, can we filter it out? Can we treat it with various different technologies? Are they effective? When are they effective? What's the best practice? How do you use it? Um, I was glad to hear Bill talk about this yesterday, but I think we need to go back and look at the work that we've worked really, really hard on as an industry in our energy and ventilation standards, which are ASHRAE 92.1 and 62.1. Uh, are they right? And we've revisited these over and over and over again. And I thought we had them right, but after seeing what happened with this, I don't know. And I'm not saying that they're right or wrong, but we need to be thinking about that. We need to define how we're going to build new systems that are more efficient, and we need to develop recommendations for how we're going to retrofit and make things right. And we need to figure out, once we figure out all those little things, type small tasks, how we're going to educate and retrain the entire industry. Um, just to give you a couple little data points, if we go back and look at the stock of existing buildings, less than 40% of existing buildings have the ability to do anything more than a minimum amount of ventilation. So if we come in and say we need more ventilation, if we do need 3 to 5 air changes per hour of outside air, that's going to be a challenge for a lot of buildings that weren't designed to do that. So these are challenges we have. We also have challenges for building operators. And I love this slide. I Googled a picture of technician changing air filter. And boy, here's a safe practice. The guy's using this looks like a leaf blower to clean out a HEPA filter. And it didn't show the picture of his face, but I would bet you dollars to donuts that there's no mask on him. What is the role of operators as we get through this? And I think we're going to expect and need them to do a lot more. We're going to need them to be responsible, not just for building safety and efficiency, which we've always charged them with, but now also to be thinking about health. And we need to educate them about the best practices to monitor and manage efficiency and health and safety. And we need to help them stay safe. Uh, Bill had a comment yesterday about, when you go in and change the filters in a building that you certainly hope have been effective in trapping the virus. Now you have something that's laden in virus, and you certainly need to have all your PPE on to properly deal with that. And you certainly need to be disposing of them properly. So we've introduced an additional risk for the people that we charge with running these buildings. So that's a couple of my thoughts. And I was just going to put a couple questions, and this will just be an open discussion. But I'd like to hear people's thoughts about what the new normal is and how that impacts us, how we're going to deal with these issues of health and safety in our educational and community college programs, what you can do to help the industry, and what should Best Center be doing to help here. And anything else you want to talk about on this topic, we've got some great folks on the line, but that's just a few things to kind of get the discussion going. So who would like to go first? Any thoughts, questions, comments?
Well, I don't know if I want to go first, but I'm always happy to start talking.
Please.
Yeah, you were talking about Zoom. After next week, I will have done 56 presentations since the middle of August. So it's been interesting. Well, you raised a number of important points, and what is new normal? I come at this more from the air quality side than from the energy side, but having been a consulting engineer and done a lot of energy work before I got into IAQ, I realized that we really need to put the two together. I think the new normal needs to be a much higher standard of air quality in buildings, but done in a way that doesn't adversely impact our objectives with respect to energy use. And that would clearly suggest that a lot more ventilation isn't the best solution. It could be a solution to just bring in huge amounts of outside air and essentially turn the inside of a building into the outside. You flush it with enough outdoor air and it's the outdoors. But I think what we need to do is solve the problems around air cleaners, which have a lot of promise and a lot of problems. It's to say it's a little bit of the Wild West. We have a small number of air cleaner types that have been actually shown to be safe and effective for reducing infection risk, and that's pretty much just UV in different applications, and we have a lot of others that may be effective, but no one has ever invested enough in characterizing them to know how they really work and whether they're really safe. And you know, so I see that as being one of the big
Y- y-
issues. But
y-
even if we just look at outdoor air, I think that there's a solution there. I think that as I suggested very briefly in one of my slides near the end, if we can do a good job of deploying sensors and doing not just temporally but spatially um, controlled demand control, we could deliver really high levels of IAQ locally and probably have buildings using less energy than they're using now. We could push ventilation rates up, but by only ventilating where we needed it, actually have a net energy benefit from that.
You know, a couple thoughts on that, Bill. One is, you know, I originally had this discussion with Marianne Piet at some point during the summer, and Marianne said, gee, it's great that you want to do more dilution and bring more outside air into buildings, but sometimes in California, that's a problem. And I thought, yeah. And then in early September in Oregon, we had exactly that occur, when we had 500 AQI of 500 here. And it's like, yeah, this is an issue. So filtration and treatment is really crucial. The other challenge I think we have, and I'm a controls person, so I tend to come at everything from a controls perspective, is that we don't have great ways of sensing air quality. We can sense VOCs, we can sense particulate, we can not, we don't do, we have some ways of sensing occupancy, but we don't have a great way of doing people counting, and we don't have any way to track uh, contaminants. So in some ways, if we had better sensing, that would help a lot as well. And we don't have everything we need there today.
Yeah, and you have to design for more zonal uh, delivery
Yeah.
of ventilation and use of air cleaners. But you mentioned the other thing, you know, that I didn't remember to touch on was resilience. I think that
Yeah.
you know we don't need most of the time 6 to 12 air changes per hour of equivalent clean air, because most of the time we're not in flu season or having a pandemic, but we need to have buildings that are much better able to adapt than it's obvious the ones we have now are.
Yeah.
You know, that's why we're having to do so much work to come up with quick fixes for
Yeah.
infection
Yeah.
prevention in existing buildings.
And most of our new low energy designs are at code minimum ventilation. We're kind of moving away from a lot of airside systems. So, and they're good systems, they're efficient, but if we need more ventilation, we need to be designing for those now.
You got to oversize the thermal components. You know, you've
Yeah.
got to have more dehumidification, that's an interesting question for the standards folks. How far are you going to push oversizing things in the interest of having more resilience in your building?
How about some of the participants? Any questions or comments, and maybe on some of the things that we've raised here?
Yeah, well, I wanted to mention the bill. I was really struck by the slide showing the changes in ventilation standards historically, especially around the time of the Spanish flu, right? And then there's that, dramatic drop off, like maybe what, 1 or 2 years after the flu was considered kind of dead, and just wondering, I mean, what can we learn historically so we don't repeat those mistakes?
Well, memory is short. That was one thing that I
Yeah.
mentioned at the end. Well, you know, if the pandemic ends and everybody feels safe again, it's
Yeah.
going to be hard to get anybody to spend money on protecting themselves against the next one.
Well, the same thing happened with UVC light during polio epidemic. Buildings were all had high bay UV light in them. You know, when they're especially hospitals to get rid of that and treatment centers. And we abandoned it. It would have been so nice to have that now. What I see as the biggest problem is all of the existing buildings. I mean, we can put in design standards all we want, but it's the existing buildings, where we need to make some impact. And I think the only way we can do that is to come up with recommendations for utilities to create programs to help address this, funded programs. I don't see, I mean, I'm coming at it, of course, from the municipal side. Trust me, the municipal government has very little money for this. And if it doesn't show energy efficiency, it can't be used, done as a project with on-bill financing, because there's no, rate of return
Sure.
on that. So funding has to be there. And whether it's grants, whether it's, a different kind of on-bill finance loan or something, but there needs to be something from the utility side, because, they're the ones who reap the benefit of our energy consumption.
Well, there needs to be some method of funding. When I think about this, I think about, if you think, just for example, about commercial office buildings, let's say as a scenario that demand for commercial office space is going to drop over the next 5 years because people are going to be working more from homes and more virtually. If you figure that it goes down 10% or 30% and you're one of the remaining people, then you're going to need to make some investment in your space in order to attract and retain tenants. So folks are going to they'll need funding mechanisms, and they're going to need to make some investment. But my biggest worry is that from the engineering community, we can't tell them what to invest in yet. So we still have some fundamental challenges with saying, this is what you need to do, and this is what it costs. Is that investment in dilution? Is the investment in treatment? Is the investment in sensing? We don't know yet. So that's a challenge. And that's why I think we really need a program to help across ASHRAE and DOE and a bunch of different places to help figure this out. Probably help from NIH and CDC and other areas as well. But funding's always a challenge. And I think it may be a real challenge in an industry that may be hurting coming out of this.
Well, but I think we can make some recommendations, and we can say, okay, maybe it's not the best thing to recirculate that air in a building just because we want to save energy. Maybe we should invest in heat exchangers or something like that and get rid of the recirculated contaminated air. I mean, we can do some common sense things.
We can engineer around a lot of things. We just need to know what it is we need to do. And we do it in labs today. We make labs energy efficient by doing runaround heat exchangers and recovering the energy. You can do a lot of ventilation efficiently, but it costs money to do it. If dilution is the answer, and I think we still are fundamentally challenged with what we're trying to fix.
Well, people can live in a space station for months. They can be, underwater in a submarine for days. If we really put the effort into air cleaners, with from the point of view that they would save a tremendous amount of energy if they worked. It's a different objective than when you're in an environment where you don't have air to ventilate with. I think that's really one of the keys to addressing this issue, especially for existing buildings.
That's a really great solution, but I've even seen solutions that will remove CO2 from air. They're really great solutions, but now that you really do need a really great building operator, because you really do need it's like the building operation technology on the space station is different than it is for the Walmart down the street. I mean, you really have to get it right?
Well, you're still going to have plenty of oxygen in your building.
Yeah, that's true.
Yeah. You're not worried about people asphyxiating. But the problem from a research point of view has been defining exactly what you need to control and to what levels with air cleaners. The ventilation is just a convenient solution because we just keep increasing it until it seems to be okay, and we never actually have to know what's in the air.
Yeah. Bob, do you have any thoughts on this?
I mean, when I think about a building, I think about the train wreck and balancing that exists probably, in most of the world. And we're talking about just increasing airflow. I mean, we got to get the pressures right first, and you got to get the airflow systems right. When you mention, RFI cell, like any PHI cell technology or peroxides, nobody's going to make a decision on it. It was a question I brought up the other day, and I didn't see anybody going towards it, and a lot of facility managers, even IFMA folks, everybody backs away from the concept and not even willing to try, because if it's not stated clearly by ASHRAE that this is the way to go or it'd be effective, we're not putting even, efforts towards that research to try to bring them in. I mean, as far as that's concerned, I've just seen a lot of problems, and I heard a lot of different people talking about that many ways. And then, we're looking for guidance from places like ASHRAE as opposed to, and I'm not saying that's, maybe it's, air balancing, uh, across America or something like that. But, if people don't want to make a decision, there's only going to be indecision.
Well, and it's also, I think, on a lot of these technologies, we have to, we need, I mean, ASHRAE's done a fantastic job stepping up, and the epidemic task force has done a tremendous job in a very short amount of time. And in the ASHRAE world, this is unheard of and remarkable. But I'll give you an example. I have a volunteer organization I'm working with here locally, and they said, "What can we do to make our buildings safe?" And I said, oh boy, I mean, in order to get this building safe and properly ventilated, it's just impossible. I mean, it would take too much time and too much money to do this. But I found a solution with UV lights, and it was actually the solution with the ceiling fans. It was an effective solution. But people came back and they said, well, but can we operate differently during COVID? I'm like, no. Can we guarantee people that they'll be safe? No. So why should we do this? Well, that's a good question. You need to decide what you want to be comfortable with. If you just open up all the doors and windows, you'll probably be relatively safe, but it's not a very comfortable or energy efficient solution. So.
If you take us, like our school, for example, when the pandemic hit, I mean, and we have probably the second largest campus in all Illinois. When you look at how we operated, we had no major outbreaks. We had people that had to stay home because they were around somebody that was around somebody, but all the measures that were taking place to ensure that that wasn't happening, we didn't really have any big issues when it came out. But could we have done more? What is code? It's nothing but minimum, right? So, how do we investigate the technologies? And this isn't just ASHRAE's responsibility. This is everybody's responsibility. But how do you invest in those technologies, confirm them? But then at the same time, we still have the problem that exists everywhere, is that you have buildings that are getting, pen jockeys checking off everything, saying that this has been commissioned and it works properly, and it doesn't work properly at all. And, how do you fix that issue too? So
that's why building operations is so important. I mean, it needs to be designed right and installed right, but you also need to have people trained right to be able to keep it working at the correct level.
Bob, can you explain what FiCell technology is?
So it's more like it's kind of, they were going for the putting ozone. It first evolved out of ozones, and there was problems with it with humans not being able to deal with it. And then it came up with a couple of different precious metals and putting hydrogen, hydroperoxides into the air, which they're claiming that it disinfects. And, in their test world, and there have been other tests on it, but it's
a brand name for a form of photocatalytic oxidation. I looked it up after the talk because I was suspecting that it wasn't a generic technology, but somebody's product, and it's PCO for those who know what that is.
Okay.
Hydroxyls and hydrogen peroxide and other reactive species.
But if it's not confirmed, again, tested, signed off on by the right people, saying, hey, this works, does it? I don't know. Let's put it in a hospital.
Well, that's absolutely right. And even things like UVC, for example, UVC has been used in a lot of applications for a lot of years, mainly to kill bacteria that grows on wet coils and to keep coil drain pans and things clean and sanitary. But in order to use this on an airborne virus, you have to expose the virus for, what is it, 2 minutes or 3 minutes or a certain amount of time. The air going 400 feet per minute through an air handler, it doesn't work. So
No, it does work. I mean, this is the
okay.
problem: is people are
Okay.
used to coil cleaning systems and don't understand that you actually can design a system to work. The EPA was testing air handler UV systems for anthrax 20 years ago, and they work. This is a problem of the popular understanding of technologies. And yes, a coil cleaning system is undersized for air treatment.
Okay.
When you say they work, William, I'm curious. They work against the COVID virus or against viruses in general. I know folks that have used UV against bacteria, but I don't know enough about the biology to say how it
Yeah.
would function with
Well,
viruses.
but viruses have RNA in them. It's got basically the same base pairs. You've got uracil instead of thymine in it, but it's the same idea. Photon breaks a bond and damages the genetic material, and it can't replicate. And one of my students is probably one of the world's experts on that. I've got his book here. Yeah. Ultraviolet Germicidal Irradiation
Wow.
Handbook.
Right.
Wow.
Nice.
It's
Wow.
got like 19, it's got 19 pages, I think, in it of rate constants from peer-reviewed studies on bacteria, viruses, and fungi. And there probably were 5 coronavirus rate constants in the literature before COVID-19 came around, including SARS-1.
Hmm.
And it's a very susceptible virus. We've done tests this year on human coronavirus NL63 and also on SARS-CoV-2, and it fits the general profile of other coronaviruses. So, the basic physics of it, if you've got DNA or RNA and you expose it to UVC, there's a dose that will inactivate it. And so the design problem becomes determining how to deliver that dose.
Right.
And what air velocity in an air handling unit affects is the amount of time you've got to do it. And so you wind up
Right.
with pretty high powered systems if you're going to do it that way. But upper room systems, highly effective. 10, 20 air changes per hour equivalent.
Yeah, that's what I meant, Bill. I mean, that it has to be designed right, and the systems we're using often for coil protection, things are moving too fast through there. So,
But here's another research gap: is
but that's a
there
research
are
issue.
only a
Yeah,
few
yeah.
there are only a few vendors that have good software for doing sizing. Why don't we have good tools for selecting UV systems or other air cleaners for building applications? You can.
Yeah.
It's easy if you want to size a coil or some other thermal hygrothermal component. We just haven't invested in making that available. There ought to be open tools for sizing or selecting your UV system, but we don't have them right now. They're limited to a few experts.
So there's a question that's come in the chat here from looks like it's from Sean about displacement ventilation. And from a COVID perspective, is that an effective strategy for moving contaminated air out of the breathing space? Is it practical to retrofit buildings for this? I think I know the answer to that one, but let me, how about the first part?
Well, what I would say about it is that no, it's probably not very feasible to retrofit. But I think I mentioned, again, briefly, because I covered a lot of ground in my talk, Hugo Lee and Peter Nielsen and Matt Sandberg have done some research on displacement versus mixing in healthcare environments. There's a really good short IEQ column in the ASHRAE journal a few years ago. And what they found was that when the contaminant source is an infected person who's breathing out infectious aerosol horizontally, that escapes their thermal plume. And they've done flow visualizations and CFD modeling to show that it can actually stratify a kind of inversion layer in a space. And so if you read their articles, they say that maybe in healthcare environments, if what we're really concerned about as a contaminant is infectious aerosol, mixing might actually be better than displacement. And you know, I think that's again another fertile area for research. Everyone thought, well, because displacement is better for building generated contaminants and bioeffluent, it's going to be better for everything, and it may not be quite that simple.
How about the question I raised earlier about what can the best center be doing to help with this? Any thoughts on that?
Peter, you've been quiet. Or distracted.
Well, no, I'm waiting to hear.
I mean,
Oh,
I think we have I think Best is already doing a great job and bringing at least IAQ to the forefront. You know, it's a small chapter in every single book. There's not much until COVID hit. You know, I mean, IAQ was out there, but nobody has taken it serious until this point in time. And I think this is just like a beginning of people to start really taking a look at IAQ. And I remember in 2005, when they started coming out with the small little black boxes that would monitor your IAQ in your house residentially and give you a report telling you how many VOCs and what else you had. And then, and most of that IAQ stuff is, well, we've been breathing this stuff for years until you figure it out. I mean, think about when radon tests started coming out. So it's just, you look at it over the years, it's one of those things. We think about the water we drink. We don't think about the air that we breathe. That's my line I use all the time.
I think it's an education problem. I really do. Who's doing HVAC and who's designing, who's running buildings? It's people who have mechanical engineering backgrounds or mechanical technology. So what do they learn about? They learn about thermal science. What do they learn about air quality? ASHRAE standard 62.1 will tell you how much outdoor air you have to bring into your building. They don't know a single thing about actual human factors and how air quality affects people and the economic case. If you want to find out how long we've been talking about this, those of us who are kind of zealots in this area, just find Bill Fisk, wherever he is now that he's retired from LBNL. I heard papers that he and Olli Seppänen were giving 15, 20 years ago about the unrealized economic benefits of better indoor air quality. This has been known within a certain community for a long time, but it's not getting out of that silo and into our educational process, both at the university, trade school, junior college level, and in professional development. But it's finally starting to click a little bit. It was actually happening before the pandemic, but it really still is something we need to emphasize.
One of the things that's interesting is that there's two relatively new health and wellness programs out today. And Peter, I'll probably get them wrong, but one is called Well Buildings Institute, WBI, and the other one is the Well Standard. One of them came out of some work done by the CDC, and the other one came out of a whole bunch of folks that had started and ran the U.S. Green Building Council for years and years. They're both pretty robust programs, and they're interesting. I mean, the one of them I know has points for things like having fresh produce available in your building and in a whole wide variety of things that you buy for points on. But it is interesting to see some programs that have some interest in industry about people complying with them for things that are outside of energy and efficiency.
Yeah, I mean, I think it has a lot to do with what we're always referring to as market transformation. Yeah. Unless the market values healthy air, and that's where I think John's presentation really spoke to that. It's not a matter of training. If it's valued, people will take it seriously. If it's just ignored, the operating environment will ignore it as well. And I think that's been the historical pattern.
I think that's true, and there's also a lot of cross benefits. This party ends up paying, this party ends up benefiting. So when I know I've worked with a lot of building owners and said, let's do things to get greater comfort and better ventilation, and they're like, yeah, that sounds great, fantastic idea, but we really just want to cut our energy bill. Because
split incentives.
Split
Who pays,
incentives.
who benefits.
Exactly. I did a big project a few years ago on smart buildings for the General Services Administration, and they're like, that's great, but we don't really have any people that work in the buildings. They're all different federal employees. We get charged with what it costs to run the building. We need to get that cost down as low as possible. So they understood the concept, but the benefit didn't accrue to them. It accrued to somebody else. So
He wasn't really emphasizing it, but John McCumber mentioned just briefly, do people believe it? And that's the problem. You believe your energy bill because somebody measured it and they sent you a bill for it. We're all paying for poor air quality all the time in our healthcare costs and in productivity, but it's an externality. We just have put that outside of what we think about in economic terms. And I've been given a talk for over 10 years on energy efficiency and IAQ and how to combine them. And until we start monetizing indoor environmental quality and including it in what we call an optimization of a design, which today is mostly just looking at first cost and energy cost or operating cost, we're going to have a hard time getting it done. And of course, all of that suggests to me that although people hate the minimum standards are the answer, the way to get a really big global change is to raise the floor a bit. It may not be where the people who are really advocates would like to see it, including me. But I've come to realize that significant changes in minimum standards may be the most effective thing we can do.
There was a question asked about what the best center might be able to contribute, and I just wanted to make a suggestion there. I also sit on the National Visiting Committee for the Biotech Center that's funded by NSF, and they've had a big conversation about this same topic going on amongst their team about what the Biotech Center might be able to contribute to address indoor air quality. And one thing that I think Best might think about is doing some kind of joint programming with those folks, because it strikes me that there's a lot of people in the building science community, myself included, that could understand a lot more of the biological stuff, and a lot of folks in the biological community that need to know more about how an HVAC system operates. The conversation we had amongst their NVC was, would it be possible to design a system that monitored for the virus load in a building? That's the way to communicate value to the building owner. If you can go in and you can measure in real time what the virus load is in their HVAC system and tell them, look how sick your building is, that's the way to convince them. But I don't know that kind of detection capability is there right yet, but the biotech folks sure would like to develop it.
Well,
it's certainly possible.
I think what we really see, Ken, is the bar is much, much lower. We just figured out recently that men and women have different temperatures at which their cognitive function is greatest. That's just been within the last 5 or 6 years that we finally figured that out, that women like a higher temperature than men. And why? Or I shouldn't say like, but their cognitive function is better.
My wife could have told you that a decade ago, Peter.
I thought you were talking about preference there. I was like, I knew that a long time ago.
Yeah, and it's not preference. It's productivity and cognitive function. So
Sure.
Again, we have no way to monetize this, I guess. We can barely measure things that appear to be measurable, like energy usage, let alone productivity. And until we start taking it seriously, it seems though, what we need is a higher bar from ASHRAE.
To piggyback on Ken's comment, if I could.
Yeah.
So Ken, you had mentioned in buildings, you know, one of the most disgusting things in all buildings is water fountains. And, you know, that water that sits there and cools all day. And when you asked to a safety person, when do you test these fountains for Legionella? And their answer is absolutely not. And what's the reason? It's because then you have to have a mitigation process for getting rid of all of that in place. And it turns into an absolute nightmare with the people that need to be notified. So where are the requirements to test for something that is as vicious as Legionella when we just kind of pretend it's not happening? When we start looking at COVID in an air system and you do that, I mean, you can bankrupt the building owner in 2 seconds. They're never going to go for that from a liability perspective. So
wait till we bring people back into these buildings that have been closed for 9 months and the water systems have been stagnant and people get sick.
That
Yep.
is
It's going to-
exactly-
Anything that
It will
can
happen.
be done prescriptively is going to be accepted much better by the design community and by owners. I think monitoring and testing are a much harder sell.
And Bill has an excellent point there. I mean, design engineers are, when I work with design engineers, they are often meticulous about trying to meet the minimum requirements of ASHRAE 62.1, which is also the state ventilation code. They're one of the things they do a great job on is they've calculated out, as we've asked for in the standard, what the ventilation requirements for each zone are and what it needs to be here and how much outside air needs to come into the air handler, because that's a liability issue for them. If they don't do that right, that hits their E&O and it's a big deal. So as Bill said, if we can bring those minimum requirements up to what they need to be, the engineering community will pay attention to that. But there isn't much driver. There is no driver to say, I'm going to design something different than what it says in the code. People design to code. It's hard to get them to say, I'm going to design to code plus.
And this is exactly the conversation we started on yesterday, where buildings have been modified over and over and over again. I happen to have a building in, I'm not going to say where, in Berkeley, that the HVAC system the ductwork has been modified. There's air not getting to places, and people do not want to go back to work because of this kind of thing.
Sure.
And, we need a more holistic approach. And again, it goes back to the cost and money and where that money is going to come from.
Sure. I thought you were going to say it was in Oakland. It was Peter's building.
No.
Well, I could think of a few buildings on the Laney campus that might fit that description, like my office, but anyway.
There we go.
Well, at Penn State, a building that's working okay is one that nobody's complaining about. That's basically how things are prioritized. I got asked to have my IAQ class help with a lead existing building certification a few years ago, and we found out that they had screwed up their pressure relationship so much that they had air going out the outdoor air intake.
Yep.
Nobody had any idea.
I remember walking through a building and having the building engineer explain to me how a certain area was the outdoor air inlet and how they were managing it. And we started tracing everything through, and we said, no, that's the exhaust. But, he was right that when he closed that, it worked differently because things were coming in backwards through the exhaust. But yeah, he didn't understand how it worked, and it wasn't documented well, and that's just common. Which once again comes back to the importance of building operators and the ability for building operators to have the ability to understand systems and to help to make some of these decisions and to help to improve the operation of the building. It's a high bar, but it's needed.
Smoke testing and tracer gas testing is really the only way you can really visually see what's going on. We're contemplating using theatrical foggers because it's cheaper and less toxic than using tracer gases to try and find some of our problems. So wish me luck on that.
That sounds interesting.
We've used fire extinguishers as CO2 sources before to do tracer gas testing, and that was kind of fun. And they're cheap.
Uh, I have a friend that has a patent on tracer gas. Well, just his process of measuring airflow without having to use a harmful tracer gas. He learned it in the nuke business, but yeah, might be something to think about there. That's the problem. People can't. The hardest thing on those big air handlers is how do you measure all that airflow correctly? So
Well, in the time remaining, I kind of like to go back to this question about, okay, what do technicians, what do our students need to know, right? And obviously there's a whole lot of work, research that needs to be done before maybe we even get to that question, right? But in John McCumber's book, he kind of points to certified industrial hygienists as kind of the go-to experts, right, for situations such as the one we're in now, right? And Peter, I know you've mentioned that a CIH specialist has come into the Laney campus, right, for all to do some consulting, right? So, I mean, is there some kind of smattering of their playbook that may kind of trickle down to the technicians and students?
Well, Larry, one of our faculty who teaches our air quality class, I've had a tough time convincing him that it was anything more than a 1 unit, 17-hour lecture class. He believes, and he has 40 years as a mechanical engineer in operations. So he knows the codes. I think industry itself needs this whole notion of healthy buildings needs more uptake. That's why we wanted to present it to the Best Center and bring Bill in as well. But as long as the market, air is invisible, and so people literally don't know what they're breathing. Some people, at a college in Southern California, there was some water penetration in that building, and nursing happened to be in that building, and they absolutely refused to go back in that building. And the facility manager cleaned and scrubbed and did everything he possibly could to clean that building out, and showed me the reports, the data, and still the nurses would not go back in that building because of what they perceived to be mold issues. So I don't know who you believe.
Well, and I recently saw a full page ad that ran in the Wall Street Journal for an office building that somebody had just renovated and they were trying to lease out outside of New York somewhere. And it said, this is a great building and it's safe and it's so we have destination elevators, so you don't have to be touching the elevator buttons when you get in. And it said it's really well ventilated. And I thought, from an engineering perspective, I don't know what that term means. And I think one of our challenges is, as an engineering community, we need to help figure out how to define words so that we can, and maybe the answer is, we modify 62.1 and we can say this is ASHRAE ventilation compliant or whatever it is, Gold Star rated or Reader's Digest or approved. I don't know what the terms are, but when we don't have an engineering term for it and we don't have an engineering definition for it, it's going to fall to marketing. And that's why I showed that poster. This is what's up in the window of the restaurant. Is this a good thing or a bad thing or an indifferent thing? I don't know. My wife looked at that and said, "What does this mean?" I don't know. So in the absence of good definition, and I get emails every week of somebody's gadget or gizmo or sensor, or we need to help people figure out what the right solutions are and allow them to help occupants know what those are so that they can feel like so that they can have some confidence that they're healthy and safe in their buildings. And that's one of our challenges as an industry.
And,
And with that, Larry, we're reaching the end of our time here. So
I think just one last point. I think
Yeah.
what I heard from Bill and from John consistently was that, yeah, the building is designed to the minimum standard. And 10 years later, what is the building actually doing? Unless there is ongoing commissioning of the ventilation system, it's continuously grading.
well,
That's
that's absolutely right. But I would take that 2 steps further. The building was
Mhm.
designed to the minimum standards. What it was constructed to was something else, and what it's been
Exactly.
operated to is a third piece. So we have challenges that we have difficulty consistently delivering what we designed, and then things don't get better in operations, they tend to degrade. So, and this
Between
is an
there
issue
and
with
commissioning, right?
commissioning. Well, commissioning is a good solution to help us assure that we can deliver what we designed, and it's a good
Sure.
tool. But documentation, FDD, analytics, continuing commissioning, audits, all of these are tools to better documentation, the use of building information model. All of these are things to help us make sure that what we originally intended to do has been delivered and continues to work the way it was maintained. And unfortunately, as we all know, in the real world, things devolve. There's
Well,
a
I
lot
think
of
that most existing buildings, if there's enough energy savings and cost savings in commissioning to cover anything that they would need to do for COVID-19. I've been working with NYSERDA on a program they've been doing where they've had some of their consultants who they work with doing studies of buildings in New York. And that's basically what's coming out of it, is that they can find energy savings by doing commissioning that pretty much cover the measures that they need to implement to be effective in terms of improving the air quality. So I think that's really important.
Larry, do you have any closing words for us?
Oh, this has been a really great conversation.
Yeah.
Hope that we can do this again sometime. And Bill, thank you so much for being part of our event. We look forward to seeing you at future events and crossing paths.
Yeah.
Let us know if Best Center can somehow assist in some of the events you're involved with.
Yep. Thank you.
All right. Thanks, everybody. Appreciate everybody's participation
Okay,
this
thanks.
afternoon.
Thank
Thank
Yeah,
you.
bye-bye.
Bye.
Take care.